Cool. All right. Well, officially welcome everyone. This is our very first Silvermint community office hours. So we're really excited. This week, we're going to have Rusty, our Director of Systems Engineering, actually give us a talk down of a few different topics. But before we dive into it, I'm actually just going to kind of give a general overview of what our call is actually going to look like and sort of tell you that from now on, twice a week, we're actually going to have a subject matter expert from our team coming to these office hours and actually giving talks on different topics. It might be around like something happening in the community. It might be around something we've just deployed, but we're always going to have time for the topics. And then at the end of office hours, we'll be able to have an open Q&A. So if you guys have any questions or anything like that, we can try our best to answer it. If you have questions that you didn't ask in the call, we ask that you join our Discord and then post in there specifically within like the Silvermint discussion, anything that you might not have had the opportunity to ask. I can try my best to answer it, but if I can't answer it, I'll make sure to grab someone that can. Again, I'm going to introduce Rusty right now and hand it over to him so that way we can go over some topics. Today, the topics of discussion are use of infrastructure as code, one-line deployments, so deployment automation, and then Rusty's experience with tooling, monitoring, and log aggregation. If he doesn't have a complete time to go over all three topics, we'll kind of roll that over into the next time that Rusty's here with us. So with that in mind, I will pass it over to Rusty.
Hey all, just kind of staring away from the screen for a moment while I set up some visual aids here, just so we can kind of illustrate. So we're, as you all know, we're in the early stages of everything right now. So there's a boundary marker, what we really feel comfortable showing, because things are fluid and changing. But what we really wanted to introduce you to was a view of the techniques and strategies that we're using to implement our technology and how we hope to, and the trajectory we hope to achieve for our node operators. One of the in my exploration of the space and working with different coins, different mining and proof of stake work, one of the things that I ran across almost universally consistent across the board was the entry point or barriers to entry for these systems was really high. Being a DevOps person and being a systems operations person for decades now, it is very clear to me that a key marker or indicator for success in any distributed application or any distributed process is the ability to easily enter and work within that space. And so the fewer barriers that we're able to present, the faster we can onboard people, the easier it is for people to get in and get excited and become a part of it. So one of my goals is to have, and I'm going to use Homebrew as my example. I'm on a Mac, it's local to my concepts. I want as close to a Homebrew-like experience for the installation. If you're familiar with Homebrew, you click a one link, you run a one-line command from curl, it pulls down the install script, it runs everything for you, and at the end of a couple of minutes of automation, you've got a system up and running. That's the experience that I want. I do not think you need a doctorate to initialize a node. That's not how things should be working. We want you to be able to focus on your business. We want you to be able to focus on, the money generation of this. We don't want you to have to focus on this, on implementing our technology. We believe that is our responsibility for you. So in that, guys, that's what we're working towards. We're leveraging several technologies right now. Like I said, we're early. We're not at the point where we're launching something that's available to people to download or to run. So we're working towards that. The tool sets that we use are GitLab, Terraform, and when we're running locally at this moment, we're running Docker containers. I'm looking at what I kind of have to show visually. I'll take some feedback from the group here. If you want to see GitLab, some people are familiar with it, some people aren't. And Kelly, don't worry, I'm not going to show any source code, just visualizations of deployment strategies. But what we're using is Terraform. So Terraform is infrastructure as code. I'm going to really briefly go over that. But what I'll do real quick before that is I'm going to give some quick context on me. So my name is Rusty Chapin. I have about 25 plus years in systems operations. I've been working on operations technology and systems technology in a whole list of companies, nearly as many companies as I have years in the industry. Microsoft, among them, the list is large, but the point is that I've got a very large breadth of industry experience. E-commerce, retail, software, healthcare, education, legal, financial, and anywhere in between, the Microsofts all the way to startup organizations. I'm back in the .com bust era. So I've got a very interesting set of breadth, and the depth for me is around data. I spent probably the largest portion of my career as a production database administrator in a number of different of the segments I mentioned. And so I've always been exposed to kind of the swath of technology. It's never been, just web servers or just storage or just networking. It's been across the whole thing. As a database administrator, I've had to operate, run, troubleshoot, maintain web servers, storage systems, file servers, database servers, of course, but it's been CPU, memory, disk, network, across the whole thing. So I've become really familiar with that whole life cycle, that whole stack, and that's what I really bring to the table. In the last several years, 5 to 7 years, I've been focusing entirely on DevOps and SRE, and so lots of automation, lots of scripting. I program proficiently in multiple languages. I'm learning Go at the moment, though I'm not finding it terribly challenging. But all of my focus, though, has been around tooling and automation in that development space. So that's me. And so you'll see, hopefully, how I'm approaching problems, and always open to feedback and criticism, and like, hey, why are you doing it this way? This seems like a better way. As you well know, in any industry right now, it has to do with technology. The landscape is so large, it's very hard to be aware of every single approach or tool. So any advice, any feedback, open to hear. So let's talk about infrastructure as code. Infrastructure as code, IAC, is a very big aspect of systems automation at the moment. It is very simply put a way to codify the systems needed to operate any system. And there's two types of infrastructure as code. The older and one most people are familiar with, Chef, Puppet, is considered imperative, meaning that you code out all of the verbs, all of the behaviors yourself, and you write all of the actions that need to happen, which is fantastic. They work. It's a very, very effective platform, a very effective paradigm. And the newer and kind of more hotness in the market right now is declarative, where your systems like Terraform, and I'm drawing a blank on other systems that are out there. There are multiple. Terraform is the one that I prefer. Declarative systems are, you tell the system what you would like to have by the end. I would like to have a web server that runs Ubuntu and runs Apache and has these paths. And then it's up to the system itself or third-party developers, often the same developers that, say, wrote the web server, to codify how to get from nothing to a web server with these paths. And so declarative and imperative are two very different patterns. Imperative is much closer to that configuration management behavior, whereas declarative is much closer to this SRE or DevOps behavior. It also puts the onus of effectively and properly codifying the behaviors to get you to where you want to be into the hands of the people who wrote the software that you're interacting with at the end. So I prefer declarative. Obviously, it means a lot less code for us. It means we rely more heavily on the groups who wrote the systems we're using to do it. So Terraform is in that declarative stack. It's as if you haven't seen Terraform, I'm happy to do a conversation with Nikki at some point about Terraform, and we can go into all that detail. But that's what we use. We run on Ubuntu, or sorry, wow, we run on Debian, and I had Ubuntu in my head from earlier. We run on Debian. Right now we're launching everything, I believe, on Buster, if I'm not mistaken. Glance at code here real quick. Yeah, Debian 11. And so we're using GitLab to trigger this Terraform code. So our GitLab installation is a local installation. So when we get to the point of sharing code, that'll be out in a hosted installation for people to use, but ours is private now. And I think what's important to say here, we use Terraform in a number of different ways. So I'm actually going to share my screen. And Nikki, you let me know if participant screen sharing is not enabled. Yeah, let me do that. So we have 4 basic stages inside of our.
Rusty, do you want to try it again?
Yep, got it. Just doing a quick glance, make sure everything's cool. All right. You should be able to see a screen with my GitLab on it now. Okay, so we have 4 essential stages, which is init, cleanup, plan, and apply. And you can see the representation for the personal launch here. The way that we work here is we have a local demo that you can run just by running the executables via a Docker compose, which brings up several containers as well as some supporting containers on the side to provide a dashboard and metrics. We use Grafana and Prometheus. So Grafana for our visualization and Prometheus for our metrics, as well as a couple of other shims right now as we get certain parts of the system built. So in our init, cleanup, plan, and apply, that is prepping our infrastructure. So init is pulling everything together. It's creating packages that we can then download or access for the latest code. Cleanup is actually a stage that removes existing infrastructure from the environment that we're in. So if you had a previous run, cleanup is going to wipe it out, basically. Plan is a part of the Terraform strategy, which Terraform maintains state for you, meaning that it knows what it ran last time and it stores a snapshot of that state. And then in the plan phase, it creates a new snapshot of what needs to be built. And then it creates a delta between those two, saying, what do I have to do to go from the existing state to the new state? And then it prepares those commands and it stores those as a plan file. And then apply actually takes that plan file and runs those commands. So we do this in these separate phases so that we have artifacts that fall out of that process. Artifacts like the state files that are separate, the previous and the next. Also the plan file that falls out so we can review the plan if something went wrong or if we need to look at it. Also to reapply it if needed. We do this in a personal phase, which means when I make a commit or a push to the demo, it creates an environment for me. That is separate than, say, if Nikki ran a version of his demo or a version of his environment, it would create an environment for Nikki. And then he can tear that down and clean it out. The next is a staged environment where it brings the changes that, say, Nikki and I both made into a single integration environment. It stages those together in a small production. And then the final is the production release where we're doing a quasi real world test scenario. And so these are all just test scenarios for us to stand up infrastructure, run the code, observe it for a while, record the metrics, capture the logs, and then be able to move on to the next release. So that's kind of all of the GitLab element of it. There was a slightly different view, which was here. Oh, no, same thing. Let's see if yeah, so you can see here, there's a slightly different view. These are the personal stage and prod. It's essentially the same infrastructure. The idea being that we're leveraging the same strategy in multiple phases through this, but we're modifying the scale at which things operate. And it's repeatable. The work that I'm doing on this infrastructure code, in like today, I deployed the ability to generate CPU and memory profiles. There's changes happening there, but this is a repeatable strategy that is able to run in multiple phases in multiple places. How does this relate to you? How does this relate to node operation? So this ties back into our and my personal approach to this, which is repeatability and boring operations. The goal of my career and the goal of what I bring to this is repeatability and boring. I want nothing to be exciting. Anything that's exciting is really an indication of failure. I want you to be able to trigger a run of this and literally have it come up and do nothing exciting other than making money. And that's the goal for us. There should be no weird, there should be no excitement other than watching dollars roll into your account. So that's a big aspect. And that's sort of the Terraform and the automation piece of this. The next step of this for us when we get to launching operator nodes for you is leveraging initiation automation, where we're writing that downloadable, runnable shell script that does all of this for you. When we're running our local stuff in our dev environments, we're running Docker, using Docker Compose and launching Docker containers. It's probably not a long-term strategy we're going to have for node operators, just simply because of the resource constraints that get involved when you start talking about Docker, having swappable memory space and all that. And maybe we'll run the dashboards and the metrics in Docker containers, but the actual node itself does best running on a VM or an actual local piece of hardware. The goal is that there should be no difference for you. If you're running in Google Cloud, you're running in Amazon EC2, you're running in Azure, you're running in your own data center on your own hardware. Maybe you're running MAS, maybe you're running Green Cloud, maybe you're running any one of these other cloud solutions. There should be really no difference for you when you run that installation script. It should recognize and identify the fact that you're in a VM, you're in a cloud space, you're on a local hardware. It will adjust itself necessarily to implement effectively and run these machines. We're still working out what these system requirements are going to look like. We know that there's a strong network requirement and there's a strong memory requirement. You know, our nodes that we're running right now are, correct me if I'm wrong, but I think we're running at 64 gigs of memory per node.
I think that's right.
Yeah, and apologies, some of you heard me talking about the fishing trip I just came back on. I've still got vacation brain a little bit. 64 gigs of memory, very, very, very solid network connections. That's where the majority of our work is done, is that network element. But yeah, I think that's as much as I can say there, or much as I have there. So I think I went over time a little bit, Nikki, but I think any questions or whatever.
Yeah, I think what we can do is open it up for questions, specifically around anything we talked about today or anything you would like to talk about next time, because at the end of the day, we're doing this specifically for our community. So we want to make sure you guys get the most out of it. If you guys have anything to say, go ahead and unmute yourself and we can take your questions. We'll leave it up for a couple of minutes.
I think this is a redundant question because you've got some really good components that you're working with that could act as, your gatekeepers or your watchdogs. I've ran a lot of master nodes, not necessarily validation nodes. I mean, similar concept, but work a little bit differently. And in a lot of those, they do have that one script, click to install everything. But then they typically work with like a third party watchdog that is used to restart the node if anything happens or things like that. Now, I think you could do this with some of the other components that you're working, but if you're really looking for that one click, there may be a watchdog component that's in there that does a restart if things go below some level or if chain's not syncing correctly. But just how that's worked in the master node space, just to give you some thought there.
No, it's great. It's an excellent, that's an excellent call out. Yeah. So there's a number of different ways that I've done this on the commercial or corporate side to build reliable systems or resilient systems. One of the conversations that we've had is how are we going to solve the resiliency problem? If you're running a single executable as your operable service, and that single executable begins to have problems, that can take a shape that is oftentimes really difficult to detect. And so how do we detect that those things are happening? This is where Prometheus metrics and having a watchdog, as you referred to it, observing those metrics and knowing what that good profile looks like. This is how things should look, and it's starting to not look that way. Let's examine this more closely. Let's take action. But also, the way you would solve this in other arenas is you wouldn't run a single machine with a single executable. Instead, you would run multiple machines, often 3 to 5 machines with 3 to 5 versions of this running, and they know about each other in some way to coordinate their behaviors, either as an arbitration, meaning you've got one that's in charge and the rest of them are just watching, waiting for that one to fail, and then they stand up, often referred to as a shared nothing cluster environment, or a more elegant and more resilient, more robust approach where all 3 are active, all 3 are sharing transactions, and you're using some intelligent abstraction or intelligent load balancing in front of them to split that traffic in measured ways, unmeasured ways, but you're load balancing across the set. And we're still kind of talking through what that would look like. If I'm going to run a node as a service, how do I solve that resiliency problem? And you're absolutely right. There will have to be watchers. There'll have to be thread watchers. There'll have to be systems resource watchers. Some awareness of the 4 golden signals, which are saturation and all throughput and all of that. As well, there has to be an ability to respond. And one of the really big challenges for me is this is my first full foray into distributed technology. I've worked almost entirely in centralized technology in my past, and so this is a new and interesting problem for me to pull apart and say, if we're truly distributed, which is our objective and it is our target, if we're truly fully distributed, how do we manage these services in a way that really actually is effective and as effective as a centralized service where we have full monitoring, we have full observability, and we can really interact with these services? How do we build that into every single node that we build? Or every single operator's experience? And so some of those questions are still up in the air. But you're absolutely right. There'll have to be some kind of watcher. We've had discussions about the fact that we're not interested in calling back to the mothership for anything. These are true satellites. When they are out there, they are out there. And that creates an interesting challenge for us in supporting the node operators in the way that we want to. We obviously want to create an environment where we're fully and truly distributed, but we also don't want to create an environment where we've left you on an island to solve your own problems. And there's not only are there challenges with resiliency and operation, but there's also challenges with expeditious updates and making sure that people are running the latest things and are receiving the benefit of the development across the entire distributed set, right? Like, how do we know about the problems you're having? And I don't know if that's going to be an opt-in for log delivery, or if it's, I don't know. Some of these problems we still haven't gotten to even probably even the questions for yet. We're still getting there. But absolutely, absolutely there'll have to be some kind of watcher. I'm excited to know that there are other people doing the single click install, the single line install. It would be great if
it's not as easy as you think. What they wind up
No.
doing is it's just a script that does a bunch of like get pulls and installs a bunch of subcomponents, and then you have like some of the biggest challenges I've dealt with is, hey, if I can run 64 gigs of RAM to run this node, I maybe can buy an extra 64 and run some other nodes too on the same node. Then you get conflicts of dependencies. And so it's worthwhile within your install to think about doing a dependency check, because that is the biggest problem we deal with, is probably dependency checks, because you wind up with a different version because you've got some component that you're running that then in turn breaks this, and then it dominoes down the thing. The other worthwhile note I will mention is I have never seen Debian as the main recommended install ever used. It's always been Ubuntu, and it's always been like a 2 rev back, with 16 dot whatever forever, even though there was like 3 versions in front of it. But there's from at least master nodes, right? You're doing something different, and I want to make sure everybody who's listening on the call, a validation node is different than a master node, in the way that it functions. So it's a little bit different of a figure. It's much more resource intensive and doing more things. But it's a worthwhile thing to apply master node concepts to this, and how they install and what they run on and how people manage them, because that is similar.
Yeah, and I think in the model that you're talking about with the master node and validator nodes, we're sort of divergent from that model as well, right? If we're pursuing truly and fully distributed, the master node concept doesn't quite fit with us. It's almost like every node is a master node. Every node takes all of the work, and so it's there's some interesting challenges wrapped up just in that in and of itself. But you're absolutely right. Like, establishing a very crisp dependency matrix and being extremely aware of everything that's happening. For instance, like you said, I could buy another node with another 64 gigs, or I could run 2 nodes on this one 64 gig. So being not only dependency aware, but also being aware of our own software. Like, am I already running on this? And what does that mean? Does it mean I crash and don't install? Or does it mean that I modify my behavior in a way to be able to run alongside myself and do that in a way that's, expandable, right? Like, maybe you want to run a terabyte of memory, and you want to run a bunch of machines all in the same, because you know that the CPU cost is very low of the node operation profile. So I can run a bunch of these, and I just happen to have this really amazing hardware sitting around, right? You're absolutely right.
I suspect you're going to have two different type of operators. You're going to have an operator like me that's trying to run his own node. But then you're going to have what's called these shared operators. So these shared operators are a totally different game, because what they do is, you say your node cost is 120,000, coins. That's what you need to stake or to, shore up. Well, you may have people that can't afford 120,000 nodes. So what they'll do is they'll go to a shared service, and they'll say, I can afford 5,000 coins. And then somebody else has got 20,000. Anyways, the point being is, you'll wind up with 15 different people that are depositing their coins within a shared service. And then that shared service has metrics around how often a block is rewarded, what their reward cost is, or what their validator fee is. They can go get their things. Typically, those node operators are taking somewhere between 3.5% to 8%. But hey, you don't have to host the hardware. You don't have to do anything. They handle it all. They provide these cool reports. They'll send you a text message when a block is won or rewarded. So you can see, you can set your phone and your message to cha-ching, every time you see that. And then you can choose to have those rewards deposited back to your wallet address, or you can choose to have them rolled back into the next node once they get to 20,000. Those guys are going to want much different API requirements because they want to automate the deployment and transferring of coins and, flagging those coins as validator node, asset, things like that. They have a different game that they're kind of playing because they're all about bringing lots of nodes online. Whereas a guy like me is going to bring maybe a node or two nodes online and then slap my hands and hope the watchdog works and be done with it.
Exactly. No, that's a really great call out. And I think what's interesting about that as well is that from our observation point, we won't actually know if these nodes are being operated in a fractional node design or if they're being operated by a wholly owned operator, right?
Nope. You could tell because of
You
the
can't, the
transfer
whole
of coins.
contract. Yeah. The
You
way
could
they
see that
distribute
there's,
rewards.
you wouldn't even see that because you'd still see them go into one wallet, and then that one wallet, because they do a lot of phantom transfers, if this makes sense. So they're all just like spreadsheet transfers. So they keep them in main like wallets, but then it's spreadsheet transfers. And then if you want to exit the shared pool, then sometimes you have a week to 2 weeks to wait to get your coins out of the shared pool because, hey, you can't take a node down to get your coins back. So that's part of your like licensing agreement or your end user agreement when you sign up for that service, is it could take up to X period to get your coins out. But that's how that works.
Right. And just to confirm, that's something that happens in your experience, Jared. That's something that happens outside of our purview, right? Like
you wouldn't know. The only way you would know is if you're doing analytics on chain transfers or like transfers where you could see these wallets growing, and so they're a masternode like deposit address, and then you could see payouts happen from that. But for the most part, they're doing a lot of work in spreadsheets to where they actually keep the coins in the wallets until you need it. Then they have a distribution wallet that it goes out from.
Yeah, exactly. And that's, I think then probably our strongest angle there is to actually, embrace that challenge and embrace that aspect of what we know will likely happen and invite people to, hey, listen, if you're doing fractional, come talk to us. Tell us.
They will also need the auto creation via an API of wallet addresses. Mm-hmm. So they need to auto create a bunch of wallet addresses because each member of the shared network typically has their own deposit address, so that they can send money to that deposit address, which is it's a shared wallet at that point, or they don't control the private key. The shared vendor would provide that, but they've got an address that they can deposit to. Then they see that that's in there, and then once it gets to a specific amount and they have enough of those, they'll pull it together for another node, and then they'll notify you, hey, your deposit of XYZ has now been deposited into this shared node, and here's your second node that's online. And then some of the really good ones will, like in spreadsheets again, they will collapse the nodes to where now you, instead of having 10% of what this node and 10% of this node, they'll now say there's node 22 that you now have 20% of, or 40% is how they do it.
What's funny is that's lighting up my fraud sensors. Like, and the alarms are like, how that sounds like a pattern that could be very easily played out in a fraudulent way as well.
You have transactions is how it works. The one that I've been impressed with the most lately is called iNodes. They only have a couple of like master nodes that they're hosting, but they're probably doing the best job in like this type of concept. Now there's a whole bunch of other ones that do this, and some of them are sketches all get out. You're exactly correct. And those are the ones that don't have like analytics and transaction records. You just kind of like throw your node into something on Discord and trust that they're going to be around in a few weeks, kind of a thing.
Yeah.
Like iNodes is pretty legit, but I think they only have 2 or 3 coins. Firo and RTM, I believe, are the 2 coins that they're doing right now. But that I mentioned to Nikki, that may be a good one to talk to do your shared node service. And I can provide a demo for you guys if you want to do it offline or some other time. Just let me know. I'd be happy to show you.
I have
5 nodes. I have 5 nodes running in there.
I'd love to see it. And it's iNodes with a Z. Yes.
Yeah, Jeff is saying that Evo nodes as well. Jeff is a great friend of mine, and he does this as well. We've been friends for a while. but
Cool.
that's another one. But look at those because it's worthwhile to know what their API requirements are, because they definitely do everything automated and integrated.
Yeah, and I think that's definitely one of the growth points for us as we go along and I think these conversations are going to be so valuable for us, right? Like hearing what it is that can enable you to move faster, go farther, more rapidly, and then developing those pieces. But absolutely that API aspect, and not just in the interaction of the of transactions themselves, but actually an API wrapped around implementation. That's going to be absolutely critical for this kind of model. I don't know. Yeah. And so this is great input. Yeah. Yeah. It's funny. I looked at a lot of this stuff when I was playing with mining in years past. The mining pools and all that, how that all exploded. That's awesome. It's awesome. Yeah, you're gonna have to make sure you're on this call weekly there. Unfortunately, you know the weekly commit, Jared.
I'll be here for sure.
Awesome.
Anything that you want to see that I'm running right now, just I'm running some RTM shared nodes that I'm like a part of, and then I'm also running a minting wallet as well with Cordal. That's interesting. And I have a total horrible, like not good coin. I only brought up the master node to show somebody how the process worked, but I have 5 nodes of this crappy coin called the Nero. But it's a worthwhile process to watch and how they work and how they set up.
Yeah.
So I've got all those that you can kind of see, and I can show you what I don't like, what I do like. But it's worthwhile. But RTM is the one that I've got the shared stuff in, and that company is hands down the best at like what they're doing right now that I've seen. But I haven't seen the one Jeff was mentioning.
Yeah, and that's Raptorium.
Yes, Raptorium. Yeah, that's just another Bitcoin clone essentially. Is all it is. So it's running on that stack, not doing it's masternode, not validator. And I know that they're similar concepts, but they're not.
Cool.
Interesting. Cool. Thank you so much for that. Yeah,
absolutely.
I will definitely take you up on the education share there, man. That would be super valuable to me. So
yeah, super happy to. At least it's kind of nice to see 3 or 4 different ways that people are skinning the cat. And I mean, you guys are doing it the best way and kind of the newest way that I think everything should be working towards. But it's good to see kind of where the past came from. And I have them running, so you can literally break them. I can snap the server and image them, and you can break them and see what dependencies they have and what they're doing. No problem. Anytime you want it, I can send Nikki the login, and you can log in and have fun with it.
Yeah, that would be awesome. Absolutely take you up on that. And to jump back a little bit, you mentioned how you'd never heard anybody using Debian. It's my personal experience, and I'm sure people in this room will be shocked at this, but it's my personal experience that like Linux flavor is a personal religious position. There's a few variants and a few more easily accessible than others, and some are more enterprise commercial and some are more open source. And me, like, this will be shocker, I'm a Windows guy. My whole world is the Pacific Northwest, right? So I grew up in this career in the Microsoft land. And so I, dabbled in, I say dabbled. My first job was at Hewlett Packard working on HP UXs. So, I mean, I dabbled, but the flavor for me is irrelevant. And I've had this conversation with Nash. He's a little resistant to this idea, but I would like for us to be able to say, choose your flavor. Pick the flavor you want, and when you're doing your implementation, and we have scripts to run for that. We can deploy to any flavor, and any being in quotes, any Go supported platform. But I would like for us to be fairly agnostic about that Linux flavor. That creates some challenges in hardening and security and cross compatibility for different, like, watchdog apps or metric apps and things like that. It creates some more challenges. Initially, we're Debian. I believe though that will likely spread out into more other popular distributions.
I think it makes your test matrix better, to be honest with you. So if you are implementing Ubuntu and Debian and SUSE and all these other flavors, you're going to wind up with a crazy test matrix with
Agreed.
specific versions and this, that, and the other. So I think it is a great idea. Even if it's Debian, I don't personally like Debian, but that's fine. I'll use it. As long as it's like this version, this image, stick with this. This is your test matrix and gets you launched faster. If you start doing that other stuff, your test matrix is going to go to hell, and it's going to get really test every time things come out. So I'm fine with a specific version that it has to be this, and that way that makes it easy that I know what I'm going to download. I know what I'm going to purchase if I'm using a VM. I know what, and as long as that's there, I'm cool. It's the run any version, and then you wind up with something that breaks, and then you get to support, and they're saying, well, maybe.
Yeah, the support becomes difficult. The upgrading the network then becomes very challenging. Also just with security, do you have the right package? Are you getting ready to upgrade with the right thing? Less is more in that scenario as well.
Being able to work on anything, because that way you are a little distributed in the sense that different security points, security posture. If you pull on Debian 11 and next thing you know, there's a vulnerability in Debian 11, now you have every node that's vulnerable, whereas maybe it wasn't on Ubuntu, 16.20 or whatever. And that one's fine. So you don't compromise your whole network if there is a security issue. So I do agree with you on that, but I would see that would be an absolute test matrix nightmare.
Yeah, and I think that solving those problems on my side is that's where the automation strength and stuff comes in. You're absolutely right. That is one of the most irritating aspects of being more widely distributed across platforms, is that you have to test all the variants, and that test matrix becomes nasty. And it becomes nasty in a number of different ways, right? Like the cross interaction of different applications, Apache running into Debian versus Ubuntu. And I use Apache because that's the thing that popped in my head. But the point is all the supporting tools have to be tested as well, right? Like we have to run tests for everything. But that automation is what makes that tenable, what makes it possible. And you're absolutely right. We're going to launch on Debian, and we're going to be on Debian and on a Debian version, and it's going to be very static until we get to a point where we feel like branching out into additional flavors, additional distributions, additional versions makes sense for us as a platform, right? And maybe it's because we have one of these shared nodes or some pressing community need to spread out into additional areas. But yeah, absolutely.
Yeah, I mean, we still have a few minutes. If anyone has one more question, I think we have enough time to answer. And then if not, I can kind of break down some stuff. I'll leave it open for a minute just to see if we have anything roll through. And again, I kind of want to preface this by saying there's a bunch of different experience here, right? Like there's people that have years experience, like someone here might not have any experience. So we're open to answer any questions. That's specifically what this is for, is people different levels of experience to ask different questions at different levels. Because we're recording this and we're going to put this out later, someone else might have the same question that you're thinking of right now. So
yeah, to add something to that as well, is I'm learning from your input and your questions as much as you're learning from my answers and our answers, right? So yeah, don't be afraid of asking the stupid question. That's not a thing.
Now, Jeff made a comment. He sent me a direct message. He was talking about the Atom ecosystem, that a shared node pool that he works in. Their hold requirement to receive your coins is 28 days. So just to let you know how that worked in that specific shared environment. So if you say, I want my coins out of this node, they're going to make you wait 28 days before they give them back to you.
Yeah, I think Kelly, I think our hold requirement is even more aggressive than that.
Yeah, so the true stake of a node, so in a shared environment, like, the node is staked. And I think that, we're still doing some research to understand what helps secure the network the best. But the number we're floating around is 6 months. That, if you are a solo node operator and you put your stake in and you run your node and then you decide that you're done, your stake is locked up for 6 months before you retain that. Now, in a pooled situation, that's different, right? Because the rules are different. The node stays staked. They can make whatever rules they want. And I think that's actually one of the most interesting things about validating on networks is that, there are so many options. You can be an individual node operator. You can be a pooled and shared node operator. You can be somebody who is like, I want a stake, but I have zero interest in running nodes, and you turn up a business that does that for you as part of, and then you sell resources or rent resources to other validators to support their efforts in validating on a network like this. So there are lots of options. It really, and there's, when you have different options, of course, you can make the rules. Different businesses will make rules. Different pooling parties will make different rules. There are reasons, I think, personally, valuable reasons to, encourage people to have a waiting period, because you don't typically want people to come in and pump and dump a coin. And that's what they're hedging against typically when we see holding periods. Also, they don't want to lose liquidity.
Jeff saying in a pooled node that Adam is in a shared environment, at least the one he uses is 48 hours to receive because they're paying that out from profits, right?
Mm-hmm,
They're not actually tearing a node down.
Mm-hmm.
They're going to keep that node running, but then they're going to pay you out from profits. So that's a 48-hour window before they do that. And you guys wouldn't care about that. That's
not at all
relevant. If they're paying profits, that means customers are happy. People are making money. Also, node operators want profits immediately because they oftentimes use profits to pay for hosting and other miscellaneous profits are available.
Yeah, and so that's true for individual, like, rewards are available immediately. There's no holding period on that. It's just the stake that gets tied up. The other type of node that we haven't talked about is the observer node. So in Silvermint, it is not advantageous for a validator to both do the work of validation and provide service of observability to the network. So for what that means is, like, validators are not really incentivized to want to share an open API related to block exploring, for example. So the other types of nodes are explorer nodes and nodes that are observing the network and have resources available for people to do the type of block exploring that especially dApp developers as well as other end users curious about where their transaction is. So that's another type of node operator. That's another type of business. Obviously, the Silvermint Foundation will certainly run an observer node, but there will be other businesses that will want to run those as well, and revenue models that would make that advantageous.
Okay, we're coming up on the hour. So I kind of just want to end this just to let everyone know, just so that again, I'm going to kind of re-preface this, I should say, but we are going to have 2 conference calls every week. This one was specifically for validators. The next one will be tomorrow. That is at 1 UTC. We will be going over our programming language called Symmetry. So we're going to have one of our lead developers speaking about that, and we're going to be going over topics. I highly suggest if you found this informative to also attend that one. That's going to be more oriented towards developers. And just to kind of give a brief overview, Symmetry is something we're building on top of our Go programming language. It's specifically for smart contracts, has formal verification in it. Again, we're going to have a lead developer there answering any questions you might have about it. So I'm going to also highly recommend that you join our Discord server, just because we're going to have any of our meeting information in there and be able to answer any questions you might have. So The next time you will see us with Rusty, at least, is next week on Wednesday. So the validators conference call and the developer will flip-flop. So while the timing is a little tentative right now, if anything changes, I will make all the required changes within Discord and let everyone know, or I'll message you personally. So thank you guys. Thank you everyone for joining. Really excited to have everyone here, especially since it's our first one. Thank you, Rusty and Kelly, for joining me, and everyone here for asking good questions. Thanks, Jared, specifically for all of your input. So a lot to think about. I'm going to stop the recording.